So this video, or rather this screencast, I guess, is just for anybody who's absent. So I'm going to be going over this lecture in class, but in case you miss it, here's kind of where we're going to go. And I apologize in advance for terrible handwriting, doing this on my iPad instead of on my computer. Today we're going to be talking about, Today we're going to be talking about experimental design. Let me write that. Experimental design is sort of a new idea, I think, for most of you. And we're just going to be going over how to start this. So the first part you have to know with designing an experiment is that we're testing a hypothesis. A hypothesis is sort of a educated guess. We use if-then statements typically in I guess you're told to use if-then statements in high school. And the general idea is if I drop a ball, then it will bounce. That's an if-then statement. Or if I raise horseshoe crabs under this condition, then they will respond in this manner. It's always written as a statement and not a question. Frequently in the papers you read, it's just written as a sentence. It is expected that there will be a decrease in the population of some species. So we're going to be doing experimental design. The first thing we're going to do is practice testing a hypothesis. In order to test a hypothesis, we have to write one, or more correctly, three. When we're writing hypotheses, there are three hypotheses for most research question. There's the primary, which is usually just labeled H. And that would be if I drop a ball, it will bounce. Then there's the alternate. It's usually written H sub A, and then finally the null. And you want to keep the variables the same throughout. So let's write a primary. Warmer water dissolves more salt. Okay, that would be and we could test that. We could put it in different temperature water and watch what happens. And if the water is warm, then more salt would dissolve. We supported the primary hypothesis. The alternative, you don't change the variables here. You just change the direction. So you could just say warmer water dissolves less salt. So notice the wording is almost identical. You just change the direction, typically in the alternate. Sometimes they're written as if you would say your primary warmer water dissolves more salt, that you could also write colder water dissolves more salt. But if you do colder water dissolves less salt, believe it or not, that's actually the same as this one. So you want to be careful that you're still testing the correct thing. The null is pretty simple to write. The null is always, there's no relationship. There is no relationship. And you still put out your variables. It would be cool if I could spell. There's no relationship, in this case, between temp and dissolving. Okay, so that would be your null. And you literally list them out this way for each hypothesis you're going to do in a project. Once you get to be like a real scientist, you don't have to do that. But the reason why I make you do this is you always need to remember, and maybe we're digging way deep back when we did the confirmation bias. When you design an experiment, you guys think that you want to design an experiment to support your primary. That's actually not true. You want to design an experiment that actually tries to disprove the null. So what you want to do is prove the null hypothesis wrong. And in doing so, if you've written your hypothesis well and you've designed your experiment well, you will support the primary. But it's an important distinction because in good science, if your experiment goes the way you want it to, you reject your null and you can support your primary. It's never possible to prove your primary, not at least at this stage. All you can do is support it. So you want to design your experiment to reject your null hypothesis. Okay, so that's what I want you to keep in mind when we're doing an experimental design. At the same time, we need to talk quickly about variables. This part at least should be review. There are three main types of variables: your independent, your dependent, and your control. The independent variable is sometimes called the manipulated variable. It's also, if it's a graph, your x, okay? Your dependent is your response variable. And it would be your y in a graph. And control is everything else. And you want these to all be the same. As similar as possible. So if we're going to use our silly experiment about warm water versus cold water, your independent variable is the water temperature. It's not warm or cold, it's just the temperature. And you can have more than one independent variable. As a matter of fact, a good experiment would have more than one. You just wouldn't just have random warm temperature. You would have maybe several. Maybe you would have 0 degrees Celsius, 20 degrees Celsius, 40 degrees Celsius, and so on, okay? As much as you can stand. Then your response variable is how it changes. So dissolution by mass, maybe, of salt. So how something responds is the dependent variable. And when we're talking about this, you want to try to imagine how something will respond. So an easy experiment like a chemical one, like the one we just talked about, you want to write that response in there. When we're talking more biological ones, which a lot of you are doing, every time you change the response variable or the independent, you have to write a new set of hypotheses. So if you're like saying something like horseshoe crab larva move more in warm water. We'll keep using water temperature. So notice the dependent there is move more. You want to make sure you understand how you're going to measure that response when you start writing these variables and designing these experiments. So these are the variables that you're going to identify. We're going to be looking at in class a really crappy, somebody else made it, but fun set of experiments, and you're going to try to identify all of these. So I'm going to stop right there. That's what we're going to start in class. I'll make another one of these for later in the week.